let's get started. I suspect there'll be a few more people coming in when they finally finish the assignment or finish printing it out. Or I must admit that being on the non-student side of the assignments is a little bit different than being the student side. And I sometimes worry about how much time and agony the instructor causes students by giving assignments, but yeah, I'm not sure I'd put it that way, but in the sense of some people take that and exercise well to, if you don't push themselves too far and then injure themselves and then, but for me, the issue becomes the way the system is set up is that students are afraid to make mistakes, right? Do an assignment and you get punished for making mistakes on assignments, right? Don't do it right, you take points off. That's how we sort of let you know that maybe you should in a different way. Um, but the problem is if you can't make mistakes, then how do you learn, right? If you always have to be perfect, the only way to do that is not to push yourself, right? And that's also a problem with management, right? Um, once I had a boss who said, "Look, if we're not failing occasionally, we're not pushing ourselves, far enough. Because if you always have to be successful, then the only way you can do that is always be safe, right? And always, if you're always being safe, then you're not pushing the boundaries. You're not pushing yourself. You're not expanding your horizons. You're just doing the same thing that you know how to do, which is not the purpose of school. But yet we create this system with grades that train students that is dangerous to push your boundaries. I have no solution for that, but and there was UC Santa Cruz when they first started the school in I think in the late '60s. They go, okay, grades are bad, so we're not going to grades. And so what they did was in every course you took, you had a portfolio of work you did, and the instructor then, uh, basically write this essay or, evaluation, right? Um, but the problem then became, students wanted grades because, how do you know how well you're doing? And when they graduated, companies wanted grades because, like, otherwise you get this. Well, here's all the evaluations I got from all my instructors. Is like, the HR people. They want to see the resume or the GPA, and then they could, and then they just go to that pile and interview them. So it was just this tremendous push, and now they give grades. Yeah, plus I know, um, some companies don't like to hire straight A students. Well, the danger there is when you're hiring someone, most of the times they're not going to sit in an office all by themselves and just do, right? They have to interact on the team. And if you're a straight A student, how well do you interact with people? Are you the type of person that, just studied and didn't have any social interaction at all or very little? Um, so those people go on to become college professors. And then the B students go on to become, right, earn a lot more money because they get real jobs. But yeah, it's a problem. So hopefully, after you get over the pain of doing the assignment, you found it useful. So any questions? So I updated the reading list to give you some more patterns to look at and some articles we're going to look at next week. The following week, I want to start talk about coupling and cohesion. And I take that material out of a chapter of a book. I will be placing the book on a couple copies of the book on reserve in the library. And I have to check to see if CalCopy still has a copy of that chapter. I used to put copies of the chapter on reserve in the library, but they can no longer get the copyright permission to do. The problem is it's too long for them to accept just a chapter of the book. So I bought 2 extra copies of the book, so I can now go, here's the entire book, and you put it on reserve, right? The good news is initially the book was like really expensive, but it's old now, so it's like $10 you can buy a copy. Okay, well, let's look at start with a pattern which is not in the gang of 4, the null object pattern. So null object, again, you have some sort of interface or abstract class defines what the object methods the object are going to accept, and then there's the real object and the null object. Sometimes you might be able to subclass the null object or the real object. The one difficulty with that is you're going to have to probably override all the methods, and you're going to inherit fields which don't make any sense. And the hard part of this pattern is the null object represents what to do in the empty case, the null case, whatever that means. And so the simplest example I have is a linked list, right? And there's always that special case, right, when there's nothing in the list, and so then you got this check for null. Okay, if the pointer ahead is null, then what do we do this? Otherwise, we do that, right? So we can create a null node for the head, right? And it's not going to contain data. It's just going to get rid of that special case where the list is empty. So now I no longer have to worry about when that first the null pointer, the head pointer goes to null. It always points to something, and so I never have that check. I always send a message to that object, right? And it will respond appropriately. And so in this case, right, I'll do one at the beginning and one at the end, right? So it represents that null case, so we no longer have to say if null, do this, otherwise do that. That's it. Right, and then, right, depending on whether it's a real node or a tail node or beginning node, we do different things. The hard part is to recognize when this might be a useful thing to do. Now, changing topics a little bit temporarily. In Smalltalk, there's 3 basic rules, right? Rule number 1 is everything's an object. Everything is an object, right? Rule number 2 is every object is an instance of a class. And rule number 3 is if you want something done, you send a message to an object. And so 5, well, the rule number 1 says everything's an object, right? So 5 is an object. And it has a class, right? So we can ask what this class is. Well, it's a small integer, right? 1.2, right? Everything in Smalltalk is an object, and all objects have a class, so it's float. And so we can go to those classes, and we can add methods to those classes, and then those objects will respond to that method. So if you want to add a foo method to an integer, you can, because it's an instance of small integer class, and so we can add it to the small integer or integer class, which small integer is a subclass of, right? Now, for those of you who worry about overhead, they conceptually this is what happens, right? But there's some optimizations where they don't actually use the integer will fit in a word, right? So they don't put a pointer to 5. They actually put 5 in there, and they do some optimizations to save space. But you can still add methods to small integer class, and 5 and 6 and all the integers will respond to it. True, right? It's an object. Everything's a small object, so true, the Boolean value true has a class, and that class is true, which is not usual, right? Now, here is a simple Smalltalk program. We're defining 2 variables, A and B. You don't declare the types, so it's like Python in that regard. And then I assign 5 and 10, and then if A is less than B, if true, do this, else do that, right? Now here's a weird thing. How is this implemented? How do we implement this if true, if false, right? In most languages, that's just a compiler construct. Well, what happens is I want to evaluate that expression. And so first you evaluate this A less than B. In this case, it becomes true. And now this becomes a method you send to the true object. And so you look in the true class, and what do? Since it's true, you evaluate that first part and return the value.
So true message.
Well, So this is one message, right? Yeah, so Smalltalk did another thing that's not normal, and that is instead of having method name parentheses and then argument list, what they did is if you've got multiple arguments, there's a keyword, the argument, another keyword, another argument. And the reason they did that is when you've got method name, parenthesis, argument, 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 how do you know what those arguments are for? And so the idea here is you give the keyword meaning so you know what that thing is for, right? That's the true part and that's the false part. No, yeah, it should tell you, indicate what they're for. And one side effect is when you look at this statement, you think it's just a regular construct in a language, right? You know, that we all come across if else statements, right? And so you think, oh, this is an if else statement, but no, it's not a statement of language, right? This is not part of a language definition. It's just a method implemented in the true and false classes.
There's still a construct. The A less than has to replace itself.
Well, because the compare operator returns a Boolean value.
An instance of the true class.
Right.
Each one first.
Well,
one of them accepting the if true.
Yeah, so what happens here in the true class, what it does, it ignores that and just evaluates that block, right? And then the false class is going to ignore that block and return the value of that. So what's happening here is instead of thinking about, oh, the compiler generating this branch, right? What's happening here is, oh no, what's happening is we're using polymorphism to implement the if statement. And it's been optimized, right? Yeah, I mean, so conceptually, right? I mean, even the standard constructs we have, like if statements, are implemented in classes and use polymorphism to work, right? So literally, we could implement the true false method in some other class, and so maybe what we want to do fuzzy logic, right? And so we can have a true or false or maybe object, right? And the maybe object should then randomly pick whether it wants to pretend it's true or false at the time, right? Based upon some rules.
Then how would you get that mapped? How would you tell it that?
Well, then we can implement the less than sign on other object or some other symbol to.
Do you have to all the objects you create, or it tries to call some standard? Tries to pass them.
Yeah, so you'd probably have different objects you want to compare fuzzily, right? You may not want to compare 5 and 7 fuzzily because that's, but
So you override
the greater than symbol in those classes.
You would override the added layers of it.
Right, yeah. Now, part of the reason I like using Smalltalk to learn object programming is everything's an object and everything is done by sending a message, right? And you're always using polymorphism, so you can't get away from it, right? Now, the reason I bring it up here is, well, nil, or they use nil instead of null. I mean, I don't know why different languages are like some are nil and some are null, right? They use nil, right? Again, it's the same story, right? There is an undefined object class, right, where nil is the single instance of it. And we can now add methods to it, right? So in Smalltalk, we can add behavior to nil. So it's possible, right? Instead of saying, if nil, do this, else do that, right? You can send a message directly to it, and it can do what's appropriate for nil. Right? So in Smalltalk, we can have, right, nil act as a general purpose null object. Now the null object pattern, right, this won't go very far in that context, because if you've got a customer object and is nil or null, what do you want to do? Well, you probably want to do something different than if you've got a order object and it's nil, right? And so you definitely need different behavior for null in those two cases. So you won't do it here, but you'll create special subclasses that act in those instances. But again, it's just another.
You subclass nil.
No, you'd subclass, customer object for,
Okay.
Right. But again, it just points out, we think of nil and null as sort of things in the language which we can't change, right? The behavior is fixed, which then makes it harder to think about the null object pattern. Because, like, what do you mean null is null, right? I mean, it's built in the language, but if you're a Smalltalk programmer, it's like, well, no, it's just an undefined object, and so it becomes natural to create a null object for a customer, because why not? I mean, when to use null objects, right? If you do nothing, right? You've got code that can interact with those classes, and you don't want them to have to do the null check all the time. If it's null, do this. If it's null, do that, right? You don't want the clients to have to check for all those special values. Oh, create a customer object, but something went wrong, and now it's null. Now what do I do? Well, okay, we can just send a message, and we'll do the right thing. Right, and here it's like, well, I mean, look, is it, how many places in your code do you have to check, is this thing null or not? Do this, right? Over here, the same thing is null. What do? I do the same thing. What if over here, I have to check for null again? The same thing. And over here, right? So if the null check starts propagating all over places, right? We're repeating ourselves over and over again. So why not encapsulate it into one object?
In C# that's annoying, because you can do things in C# like 1.toString.
Right.
But if you do null if you end up with a string that's null and you try to call a method, then it blows up.
Right. Yeah.
But it's like, just do something, just return nothing, or do something smart.
Right.
But for whatever reason, one dot method call is okay, but null dot method call
is not.
Is just an explosion.
Right.
And it's a lot of extra code.
Because now you need to check every time, right? You have to check, right? And so the null object pattern gives you, in some cases, it gives you options around that, right? You're not going to be able to do it for numbers. because numbers aren't objects, right?
That has to be something you build.
Right. But then the null object pattern allows you to get around that for your classes.
To a point. If C# because C# uses null for everything. You can't designate. I mean, you have to put the extra code to make sure that that the pointer, the reference, always had a null object.
Right.
Never had a C# null.
Yeah. So what you have to do then, when you instantiate it up, you always have to instantiate. When you come across that variable, you have to instantiate it initially with. But often, okay, if we take the customer case, right? So some sort of factory to generate a customer for you.
In C++, if you're using smart pointers,
You
the template class, you could
right.
define that to use
Right. Yeah. So different languages, right, give you different tools to, and some of them are better and some are. Objective-C, when you send a message to null, it ignores it. Doesn't do anything. Which sometimes is what you want, other times it's not what you want. But yeah. Smalltalk, what they do is when you send a message to an object that doesn't recognize, it basically switches up the class hierarchy. If you can't find it, then object has a special method called method not defined, which you can override if you want, but it throws an exception. If you don't override it, right?
You could override it.
Right. And when you do proxies, it makes building a proxy for an object pretty easy, because then you just capture that one method, right, and then you forward it on to the real object. Right. So basically, when you've got a class that sometimes is null, the reference is null, and you don't want clients to know about it, right? And particularly if your code uses that, has to check for the null in multiple spots, like, why am I repeating that code, right? If it's not there, then I'm going to do this. And when not to use it, when very little code actually uses that variable. So my example of a linked list is probably a poor one. Why? Because the only place it's going to check for the null node is inside the linked list class, right? So, and how many places? There's probably only a couple places when you add, right? So there's 2 or 3 places we're going to check, and that's it. And so it's well encapsulated, and it's not going to propagate out. So so my example, it's both those, right? There's probably only a few places, and it's well encapsulated. Yeah. Why is that an advantage? Yeah. Yeah, but also it means you've encapsulated the behavior, right? And if you need to extend it later, we can do that too. But in this case, using a null object means that we can encapsulate the behavior, and then clients don't have, the knowledge doesn't have to propagate. How do we handle this case, right? It doesn't go, we just send a message to the object and it does the right thing, as opposed to, oh, if null, do this, else do that, right? And you repeat that many places. Okay, no, it's just, I ask for a customer object and I send a message and I'm done.
So in that example, you ask for a customer object, you gives you back a null rather than having to think about the customer back. You're just calling methods on this pretend customer.
Right, yeah. And so we encapsulate that knowledge in an object as opposed to all our code that uses it has to know. Which is supposed to be one of the advantages of object-oriented programming, right? We encapsulate knowledge in an object, and then the rest of the code doesn't have to worry about how that works. Just, go do my work, right? Like then C#, you have to worry about, well, is this nil or not, right? If it's nil, then don't send this message. Otherwise, I can send a message. Simplify the client code. Well, the client code doesn't have to worry about check to see whether it's nil or null. It encapsulates that knowledge, right? Right? I can use it here, and I can use it there. I can use it different places. Yeah, basically when I got one null object, there's one of them, right? And so for different in different situations, you want to do different things based on null. It may not work so well. Right? And you start getting more classes because now everything has a null and a real one, right? This one needs some explanation. So in the linked list example, right? It'd be nice to say, okay, add something to the linked list, right? And so say it's an ordered linked list, and so you just say, you keep on passing the knowledge on, right? And what do you do when it hits the null node at the end? Well, it'd be really nice if you could then, if the null node could transform itself into a real node with that value, and then add another null node at the end. Right? So what do you have to do? Well, since you can't do that, add, hits the null node at the end. Now what do? You have to put the null node between you and the previous node, right? But how do you do that if you don't have a back pointer? Right? So all of a sudden you need a back pointer at the end to be able to do that. If we could transmute that null node to a real thing, that would make life easier. Or even in the customer case, right? I have a null customer object, and then now here's a real customer, here's a name, right? And then populate and transform that null thing into a real one. But how do you do that? Well, most languages you can't because it's an instance of a class, and then you start.
Yeah, Andrew. I'm trying to think of ways. Yeah. Because there's ways you can force it, but it's a pointer. Usually, it's going to the guy has a pointer in memory.
Right.
So if your class is bigger, if they were the exact same size, you can plus. But,
yeah, it's tricky, right? And you don't want to be that.
And it's not going
to. No, and it's never good to be tricky with memory, right? No, you're just asking for trouble later.
But then you say there was some language where object can change your class.
Yeah, so in Smalltalk you can do that, right? So you could actually, one case where, yeah, if you could have a null object transform itself into the real thing, and yeah, and that's one spot where it makes sense.
Even if someone else is pointing to it. doesn't have to know that.
Yeah, so the one warning they always, when you look at the implementation, they always warn you as well, the current implementation is efficient because if you got one pointer to it, there's not a problem. But if you got multiple pointers to it, how do you deal with that? Now all the pointers to that null object have to point to the other object. Yeah, but they warn you. Yeah, so they handle it efficiently, but they warn you that. Yeah. Implementation details. If a particular situation has multiple do nothing meanings, well, we can use either an adapter pattern or maybe the decorator pattern, right? So we can decorate the null object to have different behavior. Yeah, you might want to transform into a real object, and there it gets tricky, except for Smalltalk. So then you can try using a proxy pattern, but there's no real good solution because then you're wrapping it somehow or. And so there's this, like I said, there's the design pattern, the Granger 4 book generated a lot of follow-on books, and one of them is Refactoring to Patterns, which is just talks about how you can take your existing code and introduce a pattern into the code by refactoring. And again, they do these very, very small steps because every time you're dealing with large code base, you don't want to make big changes all at once. You should probably try it once in your life just to make sure you really understand why you never want to do that. Right? And so they do it in small steps. Right? So you have some check like this, right? And so we want to, basically do something like this. Well, just get the plan, and we're done, right? So we don't have to check to see if customers null, then get the basic plan, otherwise do something else, right? Just give me the plan, and if the customer's null object, then it returns the basic billing plan. Otherwise, it returns whatever billing plan the customer object has, right? Sort of nice, because all you have to do is you just ask for the billing plan. You don't have to think about the null case. So I say create a subclass, right, for the null customer, and then you can add an isNull method so you can check, right? And instead of checking for this, right? Now, so wherever you return customers, and you check to see if it's null, and then you return the null object instead. And now instead of checking like this, we can now check like that, right? So we've only made basically one change, right? Instead of saying customer equals null, we're calling customer is null.
in an object-oriented language like Java, because I know some languages, but to do something like not have an is null and say if customer is a
right.
null plan,
right.
Would that typically involve some reflection overhead?
If you're checking the class?
Yeah.
Yeah, it depends on the language, yeah. Yeah, that I don't know. I'm not sure how to do that in Java.
It's all slick.
Right.
It looks clean.
Right. But just be careful though when you're checking for the class of it. You have to ask yourself, what happens if you get a subclass instead of the class itself? What answer do you get? If it's,
well, yeah, in general, you have to if
right.
you have a null, if you have a class specifically to represent null objects,
right.
you say this is a null object. Right now.
Right.
I assume you'd also
Yeah. But here it's sending a message becomes more flexible.
Yeah, it's just all the class. I mean, you resolve in a base class, but you just have this kind of weird method is null in your main class.
But it's more flexible, right? Because now we have control over what it means and who. If it is a instance of this class, now you fix that, the structure becomes fixed. And then you have to worry what happens with the subclass or superclass. And so we make one change, right? Basically, add an is null method, and all of our checks become, instead of equals null, this is null. And so now we can ask what sort of operations do the customers call? Well, one is plan. So now we can add get plan to our null customer object, and the null object returns basic plan, and now we can remove that check, but just do that and compile and test. Tiny steps, right? Now, in the example, it sort of seems ridiculous because there's just one if statement, right? But the problem is that if statement could appear all over the place, right?
So you change.
Yeah. Or
I would probably
find them all. Yeah, but if you're changing just the same if statement every place, right? That's
do that all at once.
how comfortable do you feel doing that?
I tend to feel.
Yeah, so you have to pay attention to when do you get in trouble, when don't you get in trouble, right?
So with refactoring experience.
Yeah. And even when you read Kent Beck and Martin Fowler, and we talk about refactoring, they talk about doing things in small steps. They also talk about, well, I don't do these small steps all the time. It's just that there are times when you're like, oh, this is really tricky. This is dangerous. This is going to be complicated. Now they're going to slow down, right, and make really small steps. Other times, like, well, this is pretty simple, and the code base isn't that large, and so, okay, we can make larger steps, but Well, I'm not sure what issue you're talking about because, um, yeah, we have to make, even in a Java case, we have to make sure that's now a real object, not a null instance. And once that happens, the same thing in C++, right? That has to be a instance of the customer object or an instance of the null customer object. And of course, it also has to be a pointer to it. So that was one of the first steps is you add is null to, right, this parent class and the subclass. And then you find every place that returns a customer object. And then you put that is null check there. If it's null, then return the null customer object to make sure we're always dealing with a real object instead of a null. Right, and then you just repeat over and over again, right? And so then you can introduce, right, the null object.
It's interesting because it seems like the three ways that a method will tell you that it's failed, the way you return true or false.
Right.
And a lot of times it'll return null or an object,
right,
or it'll throw an exception.
Right.
And so, of course, the way that nulls end up making your code are that middle way.
Right.
But you don't necessarily want to throw an exception. It's kind of an ugly mechanism that methods have to return their success status, but there's not really a clean way without some kind of extra code construct.
Well, the latest thing in language is optionals. So then you return an optional, and then what happens is any operation you do in the optional, this doesn't have any effect.
I tried the optional, I think for the first one, but you don't even get it.
Yeah, I mean, I haven't looked at Java's implementation of them, but Swift and Kotlin are built into the language, so you have no choice.
In Java, you end up there was extra, there was more work. There was more work than just checking. Yeah.
This leads us to another pattern, which is not in the Gang of Four, called special case, which is, we can consider the null object pattern a special case of the special case pattern. So here, right, say we've got a customer object, but there may be some special cases where, we just don't know the customer, unknown customer. Something went wrong, and so we don't have the information. Or maybe a missing customer. Instead of handling those cases in the customer class itself or having special checks in code, if we don't know this customer, do this, we can create special subclasses to handle those cases. Right? That's it. Just we also say this in a smaller context. often write a method, right? There's like, oh, there's special cases we have to worry about, and then there's a general case. And often I see this done by, well, if the price is greater than 0, then we're going to do something, but oh, wait, because if the price is negative, it doesn't make sense of a negative price, right? The quantity, I mean, how do you buy -3 things? So we make sure that the quantity is greater than 0. Now we can do, okay, now we can actually, compute the cost, otherwise, well, what do we do? Well, the tax rate, tax rates are never negative, right? So we have all these, the special cases are when the price is negative, the quantity is negative, or the tax rate's negative. There's something went wrong, right? What do we do? And so we get this crazy, and the problem with this, it becomes hard to, have we covered all the cases and have we covered them all properly? We've got this nesting. So this idea of guards, well, you just check for the special cases, the boundary conditions. Okay, if the price greater than 0, else return nil. I'm done, right? So if the price is negative, I'm done. If 0 or less, I've already handled that case. I don't have to worry about it anymore, right? If the quantity is greater than 0, okay. If it's not, then return nil. Okay, again, I don't have to worry about that case anymore. It's completely handled. Tax rate greater than equal to 0. If that's the case, return nil. Now I don't have to worry about, I've handled all those boundary conditions, right? Now I can just worry about the general case, and I don't have to think about all those other weird things. Right, so there's lots of places at different levels in our code we have to worry about these special cases, right? And it's nice to deal with them in isolation, and then so we can isolate the general case from the special case, right? And we can shorten this by just doing this, right? Have a guard, all the special cases, return nil, otherwise here's what we do.
Are there any languages where you can say, like, this is an integer, not allowed to be, this is a non-zero integer, this is a counting number, and then if it compiles stuff, or not?
Yeah, well, you can create, some languages allow you to create types, right? And so you create a type of, say, positive integers or yeah.
What happens?
Well, but then what happens is it gets complicated because now you have to specify, okay, this is, a price integer from 0 to $1 million, right? And if you're outside that, but then when you're outside that range, you're going to, now you have to say, oh, but this number is a special type, subtype of numbers, which then satisfies that condition. And
I've actually tried to do something.
yeah.
Code like that, and that's a lot cleaner than what you had.
Right.
But it's just you end up having to put it everywhere.
Yeah. And so can you make a special type for a positive number, right?
Has a negative price.
Right.
But in general, I like that construct.
Yeah.
They used to teach it because there was an overhead like that.
Well, yeah. I remember the times when they said don't only have one return, but yeah, if your method is 3 pages long, it makes sense. But if your method is 3 pages long, then maybe you should think about right. Oh, yeah. No, I don't believe in the one return. particularly if your methods are small, then so a slight break from the gang of four patterns. Everyone good with null object and special case? So let's see, were there any special cases in assignment 2? Let's see, could we consider when you start a cell with no value, could we consider that to be a special case instead of most spreadsheets consider an uninitialized cell to be 0, right? Which is fine when you're doing addition because that's 0 is idempotent under addition, but has different behavior for, sort of works for multiplication too, but it's not so great for division, right? Let's see, proxy. Well, there's a standard English definition of proxy, right? It's like a proxy is someone authorized to act on behalf of someone else, right? So in the object sense, a proxy is an object that can act in behalf of another object. And the pattern, the structure of the pattern, oh, it's almost like the adapter and the decorator and the state. And that what we do is, again, there's an interface that we have to implement, and the real subject implements it, and then the proxy object implements it, and then the proxy has a reference to, right, the real object, and then it can forward requests onto the real object, which is what, let's see, the decorator does that, right? Chain of responsibility does that. The adapter does that in some regard too, right? And then the state pattern, we do this same. So basically, in this context, the proxy just is a wrapper around the rule thing and can forward the request or it can not forward the request based on the situation. So the real question is, why do we need a proxy? You know, what cases do we need a proxy? So several places where I've seen it used is, so Java probably still has this thing called remote method invocation, although I don't think it's used much anymore. So literally what you could do is you create an object and you could put it on a server, and then you could have a client code. Instead of having to open a socket and do all that, you know, network programming, it would generate a proxy for you. And on the client side, you had a proxy object, which you then call any method on the proxy that also existed on the object on the server. And the proxy then would take that request, it would transform into a network request and send it to the server, and the server would get the request, and the proxy on that side would then take the request and call it on the actual object and get the response and take the response and send it back to your proxy, and your proxy on the client side would then give you the answer. And so the proxy on the client side, what it was doing, it was forwarding the request from you to the other machine to the actual object to get the response back. So the goal there was just to hide all that network stuff, which, when you're building clients to talk to machines, right, you're doing it for a purpose. And it's nice not to have to worry about open a socket and then take this message and convert it to bytes and put them in there and then read all those bytes off the return network socket and convert them to something just like, well, let's just go call, do this over there and give me the answer. Right?
Actually used this about 3 months ago, but I didn't know about this pattern, so I thought it was really continuous. But it's nice to do it the way the pattern shows. You test the object directly, and then when you go to your client server thing, you split it, but you already know it works.
Right.
But in the code I have now, there's actually a get status function that just gets the status, and so it'll be called from a website.
Right.
That'll call the web service locally. Forward it to our server here, forward it to our data partner server,
right.
and it ends up put to the caller.
Right, yeah. And so that's one example of the proxy pattern, right? Just it's nice, right? Yeah. Then you get to do all that network stuff once and hide it from the rest of the code and
your test program literally
test
it locally.
Right.
Change the setting.
Right. Yeah. Now, more general proxy, we might do some pre-processing of the request and talk to the subject and get more, do post-processing. But what that was doing, right, it was taking that method call and has to convert it into network call and then take the network answer and convert it back to a response, right? Another example of using proxies in OR layers. And so this needs an explanation. So how many people here have used like Spring or some sort of OR layer to talk to databases? 2 people. So first, let's expand the problem, right? Most programs deal with data, and usually we have to save that data, right? And so where do we save the data? Well, we put it in a database, right? And most databases are relational, right? And so you've got tables. And in a simple case, you've got an object, and the object has fields or properties. And then, so maybe it's a person object, and then you've got a people table or person table. And then for each property or instance variable we've got here, you've got a column over here, right? And so now I got this person object and I just store it in the database. What do? Oh, I pull all the fields out, put them into an SQL insert statement, right? To insert that as a row in the table, right? And now when I want to read that back, what do? You have a select statement, and then what you do is you select the row you want, and then you pull all that data out of the row, right, that the cursor to get back, and then you put it into an object, and then you can hand it off your program, right? And then you got an address object, you do the same thing, right? And then you have a customer object, you do the same thing. And it's like really, really repetitive. It's like, why can't we write code to do this for us, right? Because it's like, here's a class, here are the fields, here's a table, and here are all the columns. And why can't I just say class, field, table, column, and give it mapping, right? And then we should be able to generate the code that does it for us. And that's what the OR layers do, is like, okay, you specify basically this mapping from this object and these fields, they go into this table and these columns, right? Now in the simple cases, it works fine, but now I have a person object. Oh, I've got phone numbers. Oh, they've got multiple phone numbers. So how do you handle that in the database? Oh, you have got a table for people, you got another table for phone numbers, right? And then you've got this foreign key over here that we're actually here that points back to here, right? So and you've got multiple phone numbers, right? Your work number, your cell number, your home number, right? All the numbers you have, right? What happens is all those numbers come over here in the phone table, and then there's a foreign key that points back to that row in the person table that represents you. So now when I have this person object and I want to put it in the database, the problem is I have this collection of phone numbers. How do you deal with that? Oh, those have to go into this table with a foreign key. So the mapping gets more complicated, right? But now when we read the object, when I want to read that row for that particular person, what do you have to do? You have to read the row, and then you have to go and find all the foreign keys in this other table that give you the phone numbers and return that and put that in the object, right? So far, so good. Now the problem is I have maybe a person object and there's maybe 3 or 4 or 5 different fields that have to go in a different table, right? And maybe one of those objects that goes in a different table, it also has a collection of things, right? And so it has yet a third table where its values are, right? And now when I read that object, I then have to go find this row and then find in this table all the rows that correspond to that and go in this table and find all, right? And then I said, so I'm doing all this huge join and select and find the data. And then it's like, well, you know, I just want to know their age, right? So now what we're doing is we're pulling in all this huge selective joins and inner joins and outer joins, and right? And it's expensive to get this object, and all I want to know is, are they over 21 or not, right? So what they do is, right, these OR layers, when you say, okay, give me the person object, well, for the phone numbers, like, okay, we're not going to fetch the phone numbers. Why? Because you may not need the phone numbers. What we'll do is we'll put a proxy in its place. And then when you actually want the phone number, you ask the proxy for the phone number, the proxy goes, oh, we don't have the phone numbers yet. So it'll go and fetch the phone numbers at that time from the database, extract it, and then give you the phone numbers, right? So they use a proxy to avoid having to do the joins, all that initially, because you may not need the data yet, right? So it's called a virtual proxy because it's like the information is not there yet until you actually want it, and then we'll go fetch it for you. Make sense? So that's an example of a virtual proxy. Another example, in Java, array lists are not synchronized. Why? Because there's overhead to synchronize things. And if you use an array list in a non-threaded environment, then why should you pay that overhead? Or you just use one method, right? But what happens if you have an array list? It's in a threaded environment, and so you want to make sure it's synchronized. Well, what you do is you basically call this method called synchronize list on, right, and pass in the array list, and you get back something which is synchronized. All methods are synchronized for you. How do you do that? Well, all you do is you have a proxy where all the methods are synchronized, and you put the array list inside of it. So now when you call add or delete or whatever you want, right, the proxy has the method synchronized, and then it will call the unsynchronized equivalent method on the array list and return the answer. Right? And of course, everyone's familiar with web proxies, right? Where you have a proxy, and you first go to the proxy, and it will cache pages for you to save the time so you don't have to go to the real network and wait for that slow response time. And you run out of time, but the proxy pattern is used in a number of different places. Same thing on it's on a modifiable list, so we can just take an array and array this and say, no, I want to make unmodified. Don't let it be modified, and right, and all it does is it wraps the array list, and when any method that is going to change the array list, you just throw an exception and say, sorry, you can't do that.
So it's a kind of a fine line